Differential Equations Section 3, Numerical Solutions. Video 2, Standard Euler Method on a Spreadsheet. In the previous video, we introduced the Standard Euler Method and looked at the theoretical basis for it. Now we're going to work through an example to show how to use a spreadsheet to carry out the Standard Euler Method. So here's the example that we're looking at. We know that our differential equation is dy by dx equals sine of xy, which we can't solve analytically, but we're told that a particular solution passes through the point 1, 0.5. Now we want to find the value of y at x equals 1.5, and we're told that to use the Euler method, yn plus 1 equals yn plus h times f of xn yn. The first part then, construct a spreadsheet to find an approximation for the value of y when x equals 1.5 using a step size of 0.1, stating the formula you've used. And then the second part, edit your spreadsheet to find approximations for y when x equals 1.5 using step sizes of 0.05 and 0.025. So we're halving the step size each time. Let's open up our spreadsheet and have a look. So here I'm using the spreadsheet in GeoGebra. You can use any spreadsheet that you like for this. I'm choosing to use GeoGebra because it has got an advantage, which is that for my f and for my h, I can specify them in the algebra window and then use them so I don't have to keep typing in the same formula over and over again, which is quite useful. So I'm going to start by putting in my function f of x and y, which is sine of x times y, and then I'm going to put in my value of h, which to start off with is going to be 0.1, and now I can start to set up my spreadsheet. Well, I'm going to put in some column headings so I can keep track of what I'm doing. So to do that, I just put it into quote marks. So this column is going to be for x, this column is going to be for y, and this column is going to be for f of x and y. And my initial values, well, I start off with x equals 1 and y equals 0.5, and then at that point my derivative is just going to be f of column A2 and column B2, like that. Now, the next thing that I need to do is to put in my x, which is going up by h each time. So in cell A3, I'm going to have whatever I had in A2, but adding h to it. And then here for my new y value, my y1 is equal to y0, just the cell above, B2, plus h times C2. So in C2, I put my f of x0 and y0. So there's my first approximation. And then I can pull this cell down to here. And then I can pull all of my cells down. And I can see what happens when I get to x equals 1.5. Now at the moment here, GeoGebra is showing me everything to 2 decimal places. What I might want to do then is go up to the options, and for rounding I might want to increase that. Let's increase it to 5 decimal places. So here's my value of y at x equals 1.5, 0.83414. Let's have a look at how I'll record this then. So I've constructed my spreadsheet. I need to state the formulae that I used. So I'm going to start by saying that for A2, I just put in that x was equal to 1. And then for A3, I did A2 plus h. And then I fill down. Then for my second column, B2, I put in the value 0.5 for my first value. And then B3, I put in B2 plus h times C2, and I've used the asterisk to represent my multiplication in my spreadsheet. And then I filled that down as well. And then C2 was f of A2 and B2, and C3 is then going to be f of A3 and B3, so I'm just going to continue to fill this down as well. And I need to specify that this is using the formulae f of x and y is sine of x times y, and h is 0.1. And then I need to write down my approximate value. So at x equals 1.5, I had the value y equals 0.83414, and that was to 5 decimal places. Now the next part of the question has asked me to edit my spreadsheet to find approximations for y when x is 1.5 using step sizes of 0.05 and 0.025. Well, this is where GeoGebra comes into its advantage, because I specified h here and I can just change my value of h. So I can go in and redefine h so that instead of 0.1 it's 0.05, and then all I need to do is to pull this down like that, and I get my value at 1.5, which is 0.84820 there. And then again I can halve h once more, so 0.025, and then going back into my spreadsheet, pulling this down. So at 1.5 I get the value 0.85536. So just recording that then, so for h equals 0.05, at x equals 1.5, I got the approximation y equals 0.84820, and for h equals 0.025, at x equals 1.5, I had the approximation y equals 0.85536. In this video, you've learned how to use a spreadsheet to apply the Euler method.